All right, let's get going here. So we are now recording Unit 8 of our Linux automation course. We're kind of recording these behind, but I wanted to get these out and record it for people who are following along the course kind of in a more asynchronous way than coming to each of our Saturdays. So let's get into Linux Automation Unit 8. Here's our announcements. Ask me anything you need to down in Discord. That's the best way to get a hold of me. And if we had any announcements or reschedules, they'd go right here. But real quick, I wanted to level set, maybe for people who are not super familiar with the course, what we've been doing. This is Unit 8, so when you're done with this, you're halfway through the course. You're approximately halfway through when you're done with today. And what have we been doing? We've been playing with automation tools, specifically around Bash and Python, and heavily Ansible. Ansible's like our main tool. We've interacted with an operating system. We've made inventory so that we can communicate with certain servers and host groups and things that we wanted to talk to. We've done admin and one-off commands because sometimes we just need to do individual tasks against servers and that kind of stuff. And then we got into variables and systems. So the first 5 weeks were really just this, everything around using your tools and interacting with your environment, right? Then the last 2 weeks, we've been doing containerized, and I called it Docker builds, but I'll probably change this to containerized, but individual container builds of services from a source. So you'd pull down some container of some type and modify it in some way, and then deploying that into an environment. And one of the questions you might have asked as we were doing that, and we kind of addressed this in the last meeting, is that then, well, from that container build, and deploying it out, well, why wouldn't I just use this full tooling? And we have all this stuff out there. And I tell you that we're not always existing in a perfect world. We don't always do everything perfectly. So some organizations are going to have to kind of use, makeshift tools and that kind of stuff. You may use Terraform in a very controlled way to deploy environments that are not fully Kubernetes, Kubernetes is like this flagship of like the best way to do containerized management, but not everybody's going to get there. Not everybody's going to have Kubernetes administrators in the organizations. Not every organization is going to accept the risk of running Kubernetes clusters. There are risks with any new tooling that you take on, and you don't have enough resources to maintain them, so you just stay down on the Linux side running containers. That is a possible thing in our environment. So we talked about that. But now we're going to get over into Kubernetes environments. So Kubernetes is the flagship. Kubernetes is the thing a lot of people run. And we're going to talk about how you can automate and interact with Kubernetes. Now, what we're going to do today has a lot of different implications and different ways that we could do things. We're going to look at it through the Ansible lens. If your company and your tooling and your team already is familiar with Ansible, maybe Ansible is the way that you interact with a tool automatically. So that's what we're going to focus on. And then we've got the rest of the course coming up. We're going to record the other 2 lessons today and keep going on back, focused on the environment and Linux systems and those kind of things. So we're going to get to all that as we go. But I just want to kind of level set that we're halfway through the course at this point, or when you finish today, you're halfway through the course. All the discussions are up in the Discord all the way up through Unit 10 for right now. So you have all that to work on if you want to. But let's get down into it. So last week, our last recording, we talked about container environments versus Kubernetes. Again, Kubernetes is the best case scenario, and if your company can get those resources and run it, sure, do it. And you might say, but it doesn't take much resources to run Kubernetes. And I say, I know, but the maintenance of it and being able to fully deploy it and those kind of things does take some resources. So not every company goes that far into containerized environments. So there's a large gulf in between just having one container running and Kubernetes, and that's container environments. And there's a lot of different ways to deploy it. Even the cloud vendors have ways to deploy that, like Elastic Container Services and those kind of things. And then we looked at a little code snippet for Terraform, and we talked about the problems and where it could break and where you could run into those kind of things. And this was just all kind of stuff that we did for last week, okay? We did a worksheet, our normal lab, right? We always have a lab of some type. And then we had our course objectives that we were covering from the original syllabus. Okay. That was our Terraform workflow, and I mentioned that you also have a Terraform plan, but not everybody always uses that. You probably should, though, because it's good before you pull the trigger to make sure that you know what you're changing. And this was our discussion last week. This was that idea that there is a large gulf between a fully functioning Kubernetes Helm deployments on everything type place and your first time deploying something, right? There's a long distance between there where we can checkpoint and make sure that we understand these different pieces. All right, so this week we're dealing with Discussion around releases and deployments with Kubernetes is our focus. And then we're talking about a push button solution for deploying Kubernetes. Why would we want a push button solution? Maybe a team needs to be able to stand up a environment and test their stuff, but they don't have permissions out there. So then I have to use a tool like Ansible and Tower, or Tower's changed to Ansible Automation Platform, some other way for them to push a button and deploy an environment where they can test their code and their, maybe end-to-end accessing of a database and reads and changes, all those kind of things that they might need to do, but they need to deploy it in an environment to test it, right? So it's testing like it's in a real system. So that kind of looks like this. Let's pull up Unit 8. The first discussion question, your infrastructure engineering teams have been experiencing problems recreating environments. The main problems have been around reliably building the exact same environment and making those builds happen in a timely manner. Those are the two problems that probably plague platform and just systems engineering teams the most. We want to make it timely and we want to make it accurate. Those two problems, they're the central problem of systems engineering. So I say go read these books a little bit on the Google SRE books for release engineering and canarying for releases. So canarying is your next version of a release. And I say, how is Kubernetes environment different in release context or from a virtual or physical server environment? So how can Kubernetes do things differently? Well, one of the answers to that is, we can point everything at a service, and a service can have multiple back endpoints and act as a reverse proxy to our actual pods. And the pods in that case become ephemeral, which is a term right here that I ask. What does it mean that a pod's ephemeral? What does it mean that its IP address is ephemeral and doesn't matter? It's like wispy, like smoke, right? It doesn't matter what happens to it. Well, the idea is the front end service that's being run inside of Kubernetes is what's being hit, and then any number of backend pods can exist. Well, if I have that control, that means that I can stand up other pods, make them the endpoint, and get rid of the old pods. And that starts to become what we call a blue-green deployment. Or if we do that on a certain number of them and have the load weighted between all of them, that's a canary deployment, right? So what's a blue-green or a canary deployment, and why would we use each of those, right? So these are kind of our questions around, we want to recreate environments, and then we want to understand what release engineering is as a set of engineers. So that's one of our discussion questions, and then you do that down in our Discord, right? You go to pop down into Discord, and you say discussion questions right here, and you go to the actual, they were out of order, so I think it's Unit 7 or Unit 8, one of them. You go find it. That's this one here. Yeah. It says Unit 7. No, that's the wrong one. Anyways, you guys can find them. They're down there. The other one says your team needs to develop a push-button solution for deploying Kubernetes for a number of different deployment teams or development teams. So your teams need to deploy into different namespaces and build these different component pieces, right? You have a development cluster that they can use, and capacity is not a consideration. So for the purposes of this, we're not worried about how much capacity they're currently using. That does become a problem because in the real world, we do always have the constraint of capacity. How much, I only have 100 deployments of this size that could run in an environment, so I can't give everybody the ability to push the button 100 times a day. That would break, right? Guys, we don't live in an infinite world, right? There's always a constraint of resources. It's the first thing you learn in an economics course. It's also a first thing you should learn in an engineering course is we only have so much, right? So I say, we want to deploy this. What piece of information do I need to supply for this? What piece of information will the team need to supply for this? Maybe the name of the environment, maybe the app that they're running. What would the different dev teams feed this into? How would they feed that into my team? Now, we did a whole course in Unit 5. We did all of this about feeding environment files in and how we might read that. So you might say, well, the team would give me an environment file with agreed upon variables, and then when I push my automation through that environment file, it would build the thing that they need. That's the way I do it. That's really the only way I understand it. There's probably other ways to do it, but that's the way that I've always done it in my teams, right? My dev team, my 200 dev teams that I tend to support, or now I support mostly research teams, but they'll come to me with, a problem, and I'll say, okay, if you can give me these things, I can stand up the environment for that problem. And they go, I'll do that every time. And I go, well, then here's a button. And as long as you do that every time, as long as you scan that and give me that little set of variables that we need, you never even have to talk to me again. You can just push this button right here and it'll always do it. Honestly, guys, when we talk about our Netflix to work time, and we want to be able to hang out and watch Netflix all day, that's something you have to get to as far as like a level of maturity. All right. What are some potential default variables you would want? Now, default variables are something else. They're that idea that what if they don't give me something? What's the default? And maybe my default namespace defaults to whatever variable of the name of the value, the app that they're using or something. That's so if they don't give me certain things, what are my defaults going to be? And then we've talked about there are trade-offs. If you give a default, but it's the wrong default, maybe it was better to just break in that environment than to give somebody an environment that isn't correct. Okay. So that's this week's talk. Our lecture on this week is pretty short because really all we need to do is understand some of the basics of Kubernetes. And this course is not on Kubernetes. So I'm going to tell you there's a lot of resources to go out there. I love the stuff on Code Cloud from Mumshad. He's the one that helped me get my CKA and my CKAD. His stuff is excellent. There's a lot of good resources directly on kubernetes.io. That's their documentation site. So this isn't a course on Kubernetes strictly speaking. But it is important that you understand that everything within Kubernetes, everything within a cloud environment, everything within most functional like automation environments is based on what's called an API. And if we know that, when we do kubectl commands, all we're doing is formatting in an imperative command line way the calls to an API that are then, they go read a certificate and validate that they're talking to the right API and that they have permissions to do the things that they're supposed to do as users. All of those things are happening behind your little kubectl command. What if I told you that you can interact with this API a different way? You can use a tool like Ansible, which in our lab environment, your team is very familiar with Ansible. So when the dev teams come to you and say, hey, you stood up that Kubernetes cluster for us, Kubernetes is there ready to serve services and build networks and do all these things for us that are the awesome things that Kubernetes is good at and deploy containers and such. We're not going to interact with that via kubectl now. We're going to use Ansible automation. So Ansible is going to be the vehicle by which we call our APIs and such. So now what happens, what does a dev team want? What does a dev team want in here? Well, they want on their different nodes, and you can have 2 nodes, you can have 100 nodes, you can have all kinds of things. Kubelet is the process that sits there and listens to the API. So the API talks to the kubelet process, and it stands up containers in the environment based on if they can go pull it from a centralized repository or if they can pull it from wherever. And kubelet is going to stand up on that node in the default namespace if you don't tell it anywhere. But namespaces are these kind of, inside of a Kubernetes cluster, everything can talk to everything. But you can only talk within your namespace by using short names. How does that work? I love Mumshad's explanation of how it's kind of like a home. If you're in my house and you call for Scott, you can get me. But if you're outside or if you're somewhere else and you call for Scott, any number of Scotts might answer you. Probably none, because we're not very common. But my point is, to call me by my short name, you have to be in my house. And that's kind of how namespaces work. So in this lab, what we're going to do is we're going to stand up by calling to the API for Kubernetes from the Ansible tool, a namespace. And then in that namespace, we're going to deploy some things. And those things would be able to then communicate with each other. And if our app teams or dev teams or whatever you want to call them that come to us and give us these requests, ask us to stand up a namespace inside of some node somewhere on Kubernetes, we can do that for them in a kind of semi-automated fashion, right? Now, you might look at this and go, Scott, I could do all of those things with flat Kubernetes files. You know, I could have, some .yaml out there, and I can just do kubectl create and do all the same things you're going to do. And I say, yes, you could, but only if those users have those permissions. We're dealing with an environment like we're playing with a enterprise environment where maybe the team already uses Ansible and the dev teams are already coming to us. We're not going to give them permissions to go run those kubectl commands directly on nodes. It's absolutely out of the question. I'm not going to let somebody just run shit as root on my environment. But what I can do is give them an ability to kick off our playbooks that will do those things and run those processes for them on their behalf, right? And then within that, we have other controls that can kind of come up, checks and all this kind of stuff, like when that thing can run. So anyways, my point is I show you guys Kubernetes because you're not going to become an expert in this course on Kubernetes. That's not even, it's kind of like an orthogonal point to everything we're doing. We're doing automation around environments, and the environment we happen to be using is Kubernetes. And the way we interact with it happens to be Ansible for today. Does that make sense? And we chose those two because they're the kings of their environments. They're the two that are winning. Kubernetes is the standard, Ansible's the standard. And there's other things that also exist, right? Like a nod to Chef and Puppet, but they're kind of going out as far as a lot of that stuff goes. So that's what we're going to be doing today is running Kubernetes and automating some of it in an Ansible fashion. Some of you might look at it and go, Scott, this doesn't seem the most efficient way to do it. And I go, there are other tools. We've mentioned these other things that we can do inside of like the CNCF framework. But the problem is that maybe that's not what your team uses. Your team's already using these tools, so these are the things that we kind of learn how to integrate in an environment. All right, so let's go down a little bit. Let's go back to then, so this is already the end of it. Those are our two discussion posts, right? So those are the things we know that we're working on. Let's pull up the lab then. We'll pull up the lab here. And this is kind of a shorter week, but we're going to go into the Kubernetes automation, learn how to automate Kubernetes tasks using various Ansible techniques. So I'm going to click in here. If you are in the course, if you're watching this remotely, this will be linked in the lab, in the book. If you're watching it now, I just linked it down in the chat. Let's move this over here so we can see it. I'll make that bigger so you guys can read it. The environment's going to stand up, and then we're going to get dropped into this. This says this lab is part of a larger set of instruction that's free from ProLUG. That's our group, the Professional Linux Users Group. This lab book for the course is right here. So here you would go, and we're in Unit 8, which is automating Kubernetes environments. Okay. Your development teams have decided to deploy environments in Kubernetes. That's what they want to use. That's what the standard is. Maybe you've got a little dev cluster that's doing Kubernetes, and they want to make sure that they can do things and interact with this way. So you've decided to look into ensuring that automation supports the different tasks that your team will need to complete. Okay. Ensure that you have Ansible modules for Kubernetes core. So we're going to install the collection for Kubernetes core. Oh, well, we'll let that finish first. Thought that was done already. And we're going to make sure that we have all the pieces that we need to interact with a Kubernetes cluster, right? We're not using kubectl. We're not interacting directly with it except to check things. But we're going to run some Kubernetes type stuff here. Let's see if we can get this to work here. It's taking its while installing Ansible in the background. Sometimes that takes like 10 seconds, and sometimes it takes like a minute or two, like it's doing right now. So we'll let that run. Okay. Come on, system. I know you can do it. So you guys can see. Seems like that's taken longer than it normally does. There we go. All right. Now it's going to set up the collection for Ansible, and it says that they're already there. So good. We've got this all installed. We're going to make sure that the dependency for Python 3 is there, because if you didn't have Python 3 Kubernetes, this wouldn't work. So we need to make sure it's there. A little bit of setup stuff. And then we're going to make this Kubernetes 1 YAML. You can call this pretty much whatever you want, but that's what I've chosen to name it. Unit 8 Kubernetes 1.yaml. That's fine. You can call it almost whatever you want. And all we're going to do is run a simple little check to make sure that we can create a namespace called testing in our Kubernetes environment. So if we wanted to real quick, we show right here that we can get the namespaces. We do not have a namespace called testing right there. You guys don't see it. Nothing up my sleeves, right? Not even wearing sleeves. And we can run our playbook. And when we run our playbook, it should go ahead and create, if it needs to, that namespace. So create a K8s namespace. And then we go and we run a Kubernetes again, and we see that testing namespace has been stood up. Okay. So what was happening there, right? This is kind of an interesting thing to think about a little bit, is what's going on, and we're going to save that off to Kubernetes 2, and then we're going to change this a little bit and give a specific namespace. So we can modify that in a second, but let's go look real quick at this Kubernetes core.k8. So what is going on here? Like what's going on with this here? So let's go look at that and then say Ansible. And here's the module that we're using. And the module does all of these things. Here's the requirements. These are the things that have to be there for this to work. And then here's a bunch of stuff. And it tells us, like, here's an API key if we had it. Here's the client certs, but it's going to use the default certs that are there if Kubernetes already has those, right? And you could change those. So if you had multiple Kubernetes clusters that you were going to interact with and you had multiple different certificates to talk to them, you could do that. Hey, thanks for the Prime subscription. Hopefully this stuff's useful to you. We're just recording the Unit 8 of our automation course right now. So I'm just kind of going through. Look at all these things that can be changed. We're not changing hardly any of those. We're just down here creating a namespace. That's all we did was this first one. Then there's all these other examples of things that we can do if we have the permissions with that certificate and that user that we're using to interact with our Kubernetes cluster. Now we do, so we're going to be able to do whatever we want. But let's modify this next part. So we're going to VI our Unit 8 Kubernetes version 2.yaml. And in here, we're going to change the name here to a variable. So instead of just always deploying testing, we're now going to say ProLUG namespace. That's the namespace. That's the name of a variable right there. That's how we variabilize stuff in Ansible. That's from Unit 5 if you're doing the automation course with us. And also if you've done our different Ansible courses, you can see these kind of things running. So yeah, Dark Coffee, hopefully this stuff's useful to you then. Yeah, we're just deploying. We have a whole playlist down in our Discord and stuff to mess with. I'll give you a link to our Discord here in case you want to hang out down there. We just hit 4,500 people a few hours ago too, so that's kind of cool. Good sized little Discord of a pretty good little community. So now let's run this, and we're going to run this playbook, and we're going to give a specific namespace called dev-app2-v1. So we're going to run this, and we're going to say build a namespace, but then the namespace is going to be a variable we gave at the command line. Well, that looks like it worked. Didn't break. So I go here, and there's that new dev-app2-v1 namespace. So what does that mean? What's the implication of what we just did? Well, what that means is in my playbooks, I could create either a base testing value like this, and that was just us testing it the first time to make sure that we could deploy a namespace. But now I have a variable called ProLUG underscore namespace. Now that's kind of a long, unwieldy. Let's just say that we gave like app underscore namespace or something. That would be the variable. And then I tell my dev team, hey, if you give me a variable file, an environment file that has these variables, and one of them would be, in this case, ProLUG underscore namespace, or if we change it to app underscore namespace, you could interact with this tooling that I've built to go and build a namespace for your app every time you push this button right here. And that button would be, you say, where would the button be? Well, that would be inside of like a Ansible automation platform or AWX, or if you're using Ascender. Ascender is a CIQ, basically an open source. What's the name of that tool? Like the Ansible Tower type. It's like a fork of Ansible before Ansible Tower kind of closed up all that other stuff with ATX. Right? Was it? Yeah, whatever that thing is. But anyways, ATX, is that what I'm thinking? I don't know. But that's all fine. So my point is, I could give a team the ability to deploy in a namespace. Or, well, at this case, we've only proven that we could deploy a namespace. And I say, okay, that's good, but what other variables could we pass in? What other things might we want to create an app? You might be thinking about that for the discussions, like, okay, the team needs to give me the namespace they want, the connect string of the database, the type of database that they want to stand up, and maybe the container image that they want to go pull out of our internal repository. And then I'll go populate all these values the way that I need to inside of this Kubernetes, inside of my playbook. And in that way, they can give me the environment file, they can push the button, and then my automation will go and build all the things for their namespace for them. Right? Does that make sense? Hopefully. So let's keep going. One of your support teams has limited capabilities to deploy in your environment. They have the ability to deploy. They're allowed to. They have been complaining of problems with the deployments every few weeks. You set out to create an automation that tests that you can create a namespace, deploy a resource, delete the resource, and delete the namespace. Those are 4 individual distinct things that are going to happen in that environment. Okay? You intend to run this automation daily as their service account. So we're making it now for us, but we're going to deploy it and run it as their service account to make sure that every morning we can do those 4 things in the environment. Because if we can do those 4 things in the environment as their user every morning, their user's probably fine. Now, that's not a universally true thing, but it is, as a systems engineer, I'm pretty happy if most of my stuff can build every morning. Most of the time, it's going to work for the rest of the day. Now, you might say, well, what if a resource fills up? Well, there's all kinds of what ifs in this world, right? There's all kinds of constraint problems that could happen, but let's just say that generically speaking, if something runs in the morning, it's probably going to be fine all day, okay? So we come down here, and we're going to say that we're going to make a Unit 8 Kubernetes test creation. And we're going to do something very similar to what we did earlier, but now we're going to call it a daily test. So let's clear this up. VI Unit 8 Kubernetes test creation.yaml. You can use YAM or YML. I don't care. Either one of them's fine. It's just that when you want to run the playbook, you do need to name it the way that we did. But you can always run it manually if you want. And this just says that it'll create a daily test namespace. If I knew nothing else about this, I know this would probably work because earlier in the lab, the same thing just worked, but with the name test. The only thing we've changed is the name daily test, so it's probably going to work. So let's hit the button and see if probably is accurate and if it does work. And it says, didn't break yet. And then maybe I check and I see the namespace. I see the namespace right there, daily test. And then I deleted it, so now it's gone. So I deleted it right there in my thing. And then now we're going to go ahead and modify that a little bit and add the creation of a pod. So I'm going to come down here, I'm going to hit O, and then I'm going to grab this component right here. This is another module call inside of Ansible. But instead of just being the general, so it's still the core K8s, but now we're creating an Nginx pod. We're generating a name with Nginx at the front, and we're going to go pull a pod in the namespace daily test, because if we didn't give it the namespace daily test, it would go into default. We don't want it to do that. We want to test, we're testing the functionality that we can deploy a namespace and then write a resource into that namespace, right? This was the second step up here of what we wanted to be able to do, is deploy a resource in that namespace. So now let's see if we can do that. Escape :WQ, and we rerun our playbook. And now we're going to build that namespace because it doesn't exist. And then we're going to deploy that pod into that namespace. And then if I go and look at all the resources within the namespace daily test, I should see that a container is being created for Nginx right now. And watch, I can do it again and see it's still creating. So it's going to take a second to create. And I say, think about all the different variables you might add. You can change the way that these names are looked at. So let's just cat unit 8 test, right? I could change, there could be a variable here, there could be a variable here around the namespace. Now this variable would match that variable, so they would be the same, hopefully. So I'm not building in different places. I want my automations to be the same. Abden over on the YouTube, how's it going? We're just recording the Unit 8, so if you guys have questions, feel free to let me know. It's kind of like we're running a classroom right now. I know I'm kind of just running through it, but if you guys do have questions that are legitimate to this, I'd gladly stop. We did this back in November, so I'm trying to now get the recording out so that people that didn't, because we have some people that do the course asynchronously, and I want them to be able to come back and look at this and go, oh, this is what the guys did on that Saturday night when they were kind of huddled down in the Discord. We do huddle in the Discord every Saturday, right? This is what we do. But if you miss it, this is the next best thing, right? And we also have a study group, which I think the study group's going right now. The guys are studying. But every week there's also a study group that some of the other guys run about the course, and you can talk through things and walk through and ask questions and work through the labs and, right? Like we got an academic community. We're people who want to get better at engineering. Okay, so we've built all these pieces. And now we're going to come over here and it says, continue building out your test creation script by adding the cleanup. So you've done all the build out. Now let's clean it up because we had those 4 steps, right? We wanted to build in the namespace. We wanted to build the deployment, destroy the deployment, and I think destroy the whole thing. So now I've got that first part. Now we're going to pause for 10 seconds. So where are we at? Shift-G-O. And we're going to add in a pause for 10 seconds right here. We're going to destroy, we're going to get all the pods, read them into a variable. We're going to debug the variable to see all of their names. This will be fun. and then we're going to delete the whole namespace. This will be kind of a fun thing. We're going to delete everything in there. So I'm just going to drop that right here. And again, here's your Ansible pause for 10 seconds. Here's your get all the pods in the namespace. So we're reading a variable in and registering it right here as pod list. Then we're printing out pod list so we can just see all the pods that have been created. That may be useful. You might report that out every day and say, hey, in our environment, we have these pods at the end of each day. That may be something you do for a compliance report or for a capacity report. How many, you want to be able to show that we've grown X amount percentage of usage, and you can say the number of pods you have at the end of the day. We're just listing them all, but we could, instead of having this, we could just count them. Right? There's all kinds of things that we can do inside of Ansible and in Python and JSON. So anyways, deploy. Then we're going to delete all the Nginx named pods, because that's what we put in their name right here, Nginx. We're going to delete all of those out of the environment right there when we see Nginx in the name. All right, escape :WQ. Let's run our playbook again, because this is one of those things I tell you guys, aim small, miss small, make small changes to your deployment, make sure it still works. That's one. And two, there's this old saying, one test is worth 1,000 expert opinions. I don't know if that code's good. I hope it's good. I wrote it and I put it in the lab, but let's test it and watch it run. So it's going to go do all the things. It's going to deploy another, it's not going to have to make the namespace because it's already there. It's going to deploy a new pod, and then it's going to destroy, it's going to wait 10 seconds, and it's going to list all the pods that are there, which will be the one from before and the one now, and then it's going to delete all of those pods. Those are the things that it should do according to what we just saw. It should tell us which they are. There's their two names, and it's going to say, hey, buddy, I'm deleting both of them. But the namespace should still be there. If I do a kubectl get ns, I should still see that daily test namespace right there. Well, one of my checks every morning is going to be to deploy that namespace of daily tests. So my last thing I need to do is delete that namespace. So in my playbook, the last thing I need to do, Shift G, O, Control Shift V, should do that. And then now we'll destroy that namespace, escape :WQ, and then run it. We're going to deploy the namespace. Well, it'll already be there. We're going to deploy one resource, wait 10 seconds, list out and destroy all the resources, and then destroy the namespace. So we've done all four of the tasks that we just defined for ourselves for this. Also, when you're watching Ansible, you can hit C to continue, but I'll let a timer run. I'm never going to modify it. See, there's only the one in there right now. Now we deleted that. If I do a kubectl get namespaces, we're not going to see daily test anymore. It's gone. We do see the original testing one that we made 13 minutes ago, and there's our dev one that we made kind of semi-manually, but with the automation tool. But we could clean those up at our leisure. But now we've done this, and I say, what other components might you use to make this more robust? What other checks might you do to test in your environment? This is a test you're going to run, again, as another user, just to check. And I say, look at you learning automation, use Ansible to interact with Kubernetes and deploy and remove resources. So you have now, if you kind of look at what you've done in this environment, probably the most robust of all this is the Unit 8 Kubernetes test. If you just look at it, you've created a namespace, you've created a resource in that namespace, or you could create multiple resources right here if you wanted to. And you're only doing an Nginx resource. You could have a database and an app server, and you could deploy containers that you've built in other labs with us. You could do all kinds of things now that you have this in your notes from your other labs. Then we waited 10 seconds, and then we just tore it all down. We got all the information. Now, strictly speaking, these two aren't needed. You don't need these for this playbook. You could just destroy everything. And this actually says destroy the ones that just have Nginx in the name. So this one does require this to have been run. But technically speaking, you could just delete all the resources that are in there. And actually, if you deleted the namespace here, and there's a variable, I don't know, there's a argument I think that we can go look up that causes this to override. It'll delete all those as you run it if you wanted to. But we wanted to see what had we deployed, what were the values that were there, show them to us, and then go ahead and delete them. And maybe we wanted this list. One of the main reasons I would probably have wanted this list is if I were automatically going and cleaning up namespaces and environments, I would want to see what resources were in there before I destroyed them. And then even if I was automatically destroying them because they were so old in a dev environment, I could also pull this out and still have this be in a report, and it would tell me what it destroyed. And that might be useful for certain reasons. Okay. So this is Lab 8. This is Kubernetes automation. If we step back over here for a second again, the goal of this week is now to use a tool that your team is very familiar with. You're the underlying Linux systems engineering, platform engineering team, and you use Ansible. But your dev teams are insisting, or maybe your company's moving forward into Kubernetes, and you still control the environment and the underlying platform. And then you still have to stand up the environment so that your dev teams can do the things. Now, looking at what we just did there, some of you may very astutely say, well, I have OpenShift for that. OpenShift is this awesome tool I have, and OpenShift actually does all that stuff for me, Scott. And there's a cool little web page, and my dev teams can just go click in the web page and get their resource. And I say, that's wonderful. Your company's paying a lot of money to Red Hat for that. OpenShift is a great tool. My brother's the lead OpenShift administrator at his company. He runs that for his whole company, big insurance company. But that being said, if you're a company that's kind of just adopting this stuff and you have a smaller IT team, this could be a way that you do it. And I would say if you don't have a good amount of money in your organization, maybe your teams are just scraping by to get, components working, you may use Ansible in this way. This is we're somewhere between, an initial deploy of something and the perfect CNCF deployment. We're somewhere in between there, trying to keep our systems working as automation engineers. You don't always have the perfect tools, guys. You just have to make it work with what you get, right? I often use that quote from Gladiator where he's like, whatever comes out of that gate, we've got a better chance if we stay together. Remember, and then they stay together and the chariots are all trying to get them and they end up killing all the chariots. It's a battle of Carthage. They're supposed to be just run over. They're supposed to just be killed, but they win the battle because they stick together, right? And that's kind of the idea here is we can understand simple tools and we can know how to use our tools, and we don't have to have the flashiest expensive tools. We can still do a lot of this functionality as systems and automation engineers. So, okay, I'm not going to go on that too long, but I'm going to tell you that is our recording for Unit 8. I'm going to be back in a little bit to do our recording for Unit 9, where we're going to shift over to building and deploying Linux systems in a modern way, and we're going to use a tool called Werewolf. I'm a big fan of Werewolf. I think it's an excellent tool. I might be doing speaking at scale in a couple of months on this, so I'll have a recording of that if we do it as well. But next, we're going to build and deploy systems, and then we're going to harden those Linux systems in a modern way for like high performance compute and really any standardized large environment. So that's what we're going to be doing next week. All right, or well, in a few hours. But all right, I appreciate you guys coming. I will see some of you guys later, and thanks for working on Linux and doing this stuff with the Professional Linux Users Group.